Welcome to John Muir Land Trust Twilight 2020, Stargazing with Astronomical Society of the Pacific. In just a few moments, we'll get started.
And as we are all waiting, why don't you go ahead and announce yourself in the chat and maybe say what your favorite planet or star is or constellation. We'd love to hear from you.
And also, I wanted to say happy birthday to Amelia, one of our stargazers. It is her 12th birthday today. Happy birthday, Amelia. Thanks for joining us.
All right, we have someone who likes the moon. Anyone else out there like Saturn or Jupiter or any of those? Orion? All right, we've got a Saturn. Oh, and the Big Dipper. That's one of my favorites as well. We have Mars. Pluto, another Orion's. Milky Way. We've got the North Star. Hi, if you're just joining, we're just asking you to go ahead and announce yourself in the chat and tell us what your favorite star or planet is. We have Pegasus, another North Star, and Mars. Got Sirius. Another Orion, Big Dipper. All right. Oh, and always the summer triangle. That's great. Great way to orient yourself. Again, the Milky Way. Right. We got a lot of folks out there liking the Milky Way.
It's always fun in the Bay Area if you can find a little nook away from all the light pollution. You can sometimes find a few spots where you can see a little bit of the Milky Way. It's always fun. In the hills, sometimes there's a few spots where you can actually pull over and take a peek. It's good for meteor shower observing too.
All right, we have Venus, Cassiopeia. Of course, the sun.
Wouldn't be here without it.
All right, so we've got 73 people joining us here today, and it's a bit after 4, so I think we should go ahead and get started. All right, so let's start off with a little bit of housekeeping. So this webinar is being recorded and all participants are muted, but we would love to hear from you. So please use the chat features and the Q&A features to ask our participants questions. And you can use you can find the Q&A and the chat buttons at the bottom of your screen. And maybe, Brian, if we could move on to the next slide, please. Perfect, those are the housekeeping items. Make sure to use the Q&A and the chat. All right. Welcome to John Muir Land Trust's Twilight 2020, Stargazing with the Astronomical Society of the Pacific. Thank you all for attending. The presenters feel so blessed to be a part of this community who cares passionately about the restorative powers of nature. We are wishing you good health and well-being, and we especially want to think of our friends preparing for fires and evacuations this week and fighting fires. Thank you. So my name is Hannah Hodgson with John Muir Land Trust. I'm the Community Programs Manager, And I'd like the other presenters to introduce themselves, starting off with David.
Hi there, I'm Dave Prosper. I work at the Astronomical Society of the Pacific, where I help administer the NASA Night Sky Network program that brings amateur astronomers together with the public to bring the stars down to Earth.
Hi there, my name is Stephanie Becker and I'm a board member for the John Muir Land Trust. And I'll be looking at the Q&A and chat today, so hope to hear from you throughout the webinar.
Hello, my name is Brian Hayes. I'm the Technology Director here at John Muir Land Trust, and sometimes I volunteer out on the trails as well. Hope to see you out there someday.
Thanks, team. And also thank you to John Muir Land Trust board members for joining us today, as well as other staff. Thank you for being here. And we also have 77 people joining us online, so thanks for being here. Please announce yourself in the chat with your favorite constellation or planet. And also this photo that we have on the screen here is of Dave, our presenter, who is presenting out at Fernandez Ranch during Twilight 2019. So to begin, I would like to tell you a little bit about John Muir Land Trust. Our mission is to protect and care for open space, ranches, farms, parkland, and shoreline in the East Bay. We define the East Bay as Contra Costa and Alameda counties. And our service area, you can see here, this is where we protect land. And you can see the dark orange spaces are the properties that we have preserved, many of which you can visit, and I recommend that you do. So with more than 3,500 acres and 17 properties now under John Muir Land Trust stewardship, many of the most beautiful places in the East Bay are permanently preserved for recreation, wildlife, and scenic views, like this one. Visit jmlt.org to learn about visiting these properties today. And as a part of John Muir Land Trust's vision, we foster environmental awareness and ensure that our natural areas enrich your community. We host this stargazing event, Twilight, to encourage you to visit our properties and enjoy the wonders of nature. You, like these folks here, may have joined us at Twilight in the past at Fernandez Ranch to meet wildlife, gaze at the stars, and learn about what happens in East Bay Hills when the sun goes down. Thank you for joining us again today. And although there aren't any telescopes at Fernandez Ranch this August, we encourage you to visit today or this weekend. You will find 1,185 spectacular acres for hiking. Fernandez Ranch is open from sunrise to sunset, located off of Highway 4. And if you do visit Fernandez Ranch, keep your eyes open for spectacular views, beautiful sunsets, clouds, and the moon like you see here. And before we hear from David about the sky tonight and constellations, we'd like to hear from you about your recent lunar observations. So you may have been keeping a moon journal in preparation for this event, and we have a poll for you. As soon as I can pull it up. All right, so the question is, based on your observations and the chart that you see here, do you think tonight's moon will be waxing gibbous, waning gibbous, waning crescent, or waxing crescent? I'm going to give a little extra time for this one because I know you might be looking at the chart and thinking, what did the moon look like recently? I understand. All right, a few more
You may
seconds.
even be able to take a peek and see right now.
Good point. Thanks, Dave. It's not cheating. All right, so the answer, I'm going to share the results with you all. Everyone, most folks are saying a waxing gibbous, and that is correct. That is what we're closest to right now. So with that, I would like to hand over the presentation to Dave.
Alrighty, thanks, Hannah. And just as a quick follow-up, phases of the moon, there's a fun thing you can do at home if you just have, say, a globe or golf ball or baseball, basketball, some sort of ball or orb. Egg will even work. Go outside when the sun's still up and you can also still see the moon, and then hold it up, your little moon up, and see if you can match the phase of the moon with your actual moon that you're holding in your hand. When you do that, you'll notice that it's at the same angle that the moon is to the sun. Because the moon itself, while it's bright, doesn't actually make any of its own light. It's just the light it's reflected off of its surface by our sun. And I have a quick demo. There's a caveat with the demo. It's not 100% accurate as to positions of things in the sky. I have a little sun moon or earth moon model, but it's a little difficult to kind of in this small space to see it. But basically, you can also take a lamp if you have no sun, and you can make the moon resemble the phase that you see right now by adjusting its angle. And we're kind of here right now. So there you go. And with that, what else will we see tonight? The first thing you might see is the moon, but you might want to know where some planets and stars are, and we're going to show you how to find them. So where are Jupiter and Saturn, the giant planets? We'll also find out where to look for Mars and where to find the North Star and the Summer Triangle. Some of the folks in the chat were discussing those earlier, and I'm extremely glad that we're going to chat about that. And in our next slide, we'll start taking a look at the giant planets. Now, this is a sort of a quick model to scale size-wise of the planets in our solar system and Pluto, controversial planet or dwarf planet. And as you can see, Jupiter is clearly the biggest planet in our solar system. It's also, if you took the sun out of the solar system, it would contain most of the material in the solar system. Funny enough, the sun is so much bigger than Jupiter. You put it back in, the sun actually has most of the material. But you could say Jupiter has the most planetary material. Now, next to it is Saturn. You might be thinking to yourself, where are the rings? Where are Saturn's rings? Well, if they were to be included in this picture, it would just make it a little messy. So they're just removed. They would also kind of stretch out beyond this picture as well. And to be fair, Jupiter and Uranus and Neptune, they also have little rings as well. But we're just looking at the sizes of the actual planets themselves. And you can see Earth there where we are in comparison size-wise to everyone else. And to the right of Earth is Venus. And then next to it is Mars. Mars is actually fairly small compared to Earth, but it's still much bigger than, and here's actually a little Earth-Mars comparison. You can also see it's still much bigger than the next planet over, which is Mercury, which is also much bigger than Pluto. And funny enough, keep Mercury in mind as we move on to our next slide, because that'll be a good size comparison. Now, what we have here is a beautiful, it's called a composite image of Jupiter. Composite just means several things were combined together. And so they took data from several telescopes to make this beautiful picture of Jupiter. And if you looked at Jupiter with a telescope, you would see something fairly similar to this. It won't be as detailed, but you won't see that glowing stuff at the top. That is an aurora or northern lights, so to speak, but for Jupiter. It's a very powerful magnetic field, and that is part of the cause of that giant glowing energy field up there. To the right of Jupiter, you can see that it has 4 moons, and you also see the red spot, and the red spot is huge. It is larger than the Earth. It is larger than these moons, which are planet signs. And these 4 moons are, starting from the top down, Io, Europa, Ganymede, and Callisto. And if you have binoculars, you can even see them tonight. They'll look like small little dots. And but they'll be on either side of Jupiter, almost looking like stars. And interestingly enough, that's almost exactly what Galileo saw when he discovered them in 1610. It took him a couple of weeks of observing to realize that they were actually moving, these stars were actually moving around Jupiter and were moons. And that's why these are called the Galilean moons. They're not the only moons around Jupiter. It has about, as of today, the official count is 79 moons, but most of them are asteroids or other objects that Jupiter has captured because it's so big. It just has a lot of gravity. Anything that comes near it, it's a good chance it's either going to get flung out or pulled in. Now, but these 4 moons are fascinating because they're so big, they're little worlds in their own right. And you can see, let's see here. You can see how, we'll start from the top, Io, looking like a pizza. It looks very much like a pizza because it has lots of volcanic eruptions. It might be the most volcanic object in our solar system. At any time, there are eruptions just occurring on its surface. And next to it, down below, is Europa. And Europa, it looks quite different. It's a little ice ball. That's why it looks so smooth. And that's because ice is constantly erupting from below. It's kind of always, they call it resurfacing. But if you look up close at Europa, and we have with some space probes, there's barely any craters on it. And because of the water constantly coming up and making this ice, they think that there might be liquid water underneath the ice, and maybe even there's a possibility of life that might look something like the stuff we see by the vents, like these heated lava or oceanic vents deep in our ocean, or maybe something entirely different, or maybe nothing at all. We don't know, but we're going to be sending, the NASA and the European Space Agency are both sending probes out to check out Europa in later this decade. And interestingly, both Io and Europa are fairly close in size to our own moon, because Earth actually has a pretty big moon. So props to Earth. But that's not big compared to Ganymede, the next one down, the grayish moon there. It actually is the largest moon in our solar system. It's so big. This is why I told you, remember what Mercury looked like earlier. It's bigger than Mercury. It's bigger than a planet. It's huge. And it also has an interesting surface. You notice that it has some craters, but it also looks smooth in other areas. They think that that might also, like Europa, have a subsurface ocean. And all those same interesting thoughts about Europa also apply to Ganymede. Maybe not as much. Maybe as much. We don't know. We'll hopefully find out. And at the end there is Callisto. It's just a very heavily cratered moon. It might have one of the most heavily cratered surfaces in the solar system. So you got 4 worlds that are all very distinct on their own, and they're all very fun to look at in a telescope, along with the red spot on Jupiter and its cloud bands. Even with a fairly small, telescope, you can see some detail in Jupiter, and you can see these moons, and they'll actually change position during the course of the night. Even an hour later, you'll see different stuff. And so if we go to the next slide, thank you, we're going to check out Saturn. And you won't see these beautiful rings in binoculars unless you have extremely large ones, but it'll still look very bright. And you might notice it looks a little squished, and that is the rings. Interestingly enough, Galileo was able to see the moons around Jupiter with his telescope, but he couldn't quite make out the rings around Saturn. He just noted that it looked like there was something off. Maybe it had handles or something. But Saturn, in addition to its beautiful rings, also has many, many moons. It currently, I believe the count is 82 moons. And as you can see, they're also, many of them look very different. And one in particular, Titan, is a big fuzzball. We don't have a very detailed map of Titan, despite sending probes to Saturn that have even checked out Titan, because it's covered in a thick, thick haze. It has a thick atmosphere, thicker than Earth's atmosphere, if you can believe that. A moon has a thick atmosphere, and it also even has its own weather system. but instead of water being the driving force for that, it's methane, because it's very, very cold. So there's methane ice, there's methane liquid methane seas, and methane rain. So it probably doesn't smell very good there. And also, there's some interesting thoughts about if there could be some sort of strange life on there too. It doesn't seem like there's anything very complex there. We've landed one probe on it, and it didn't see much, but people want to study it some more, and they're actually talking about sending either a little submarine, and I believe they approved a little helicopter to actually go out there and check it out. And below Titan, there's actually another interesting moon. It's another one of these icy moons that has something else underneath, Enceladus. It shoots geysers constantly from its surface. It actually shoots out so much water that it's causing a little ring to form around Saturn. Not the big rings that you're seeing in the picture, but a little kind of thin ring on the edges. And yeah, like the moons around Jupiter, there's a lot of tidal forces acting on it, and they think that might be partly why that this is going on. And of course, people want to check that out too. And the fortunate thing about Enceladus shooting lots of water from it below its surface out into space means we don't have to land anything onto it and try to get under the ice. So despite being much further out than, say, the moons around Jupiter, it might be easier to collect a sample. So who knows? The other moons are all much smaller than Titan, but they're all, you can see some of them look kind of more clumpy and more like asteroids. Saturn's interesting with its moons because it has so many, but it also has many that are very, very, very small and are almost ring particles. And there's a debate about where the cutoff is between a moon and a ring particle or moonlet. Oh, what's the name of Saturn's moon between Hyperion and Rhea? Let me see here. Oh, that got cut off. My apologies. That's Mimas or Mimas. I've heard both pronunciations, M-I-M-A-S. You may have seen it in some pictures. It's called the Death Star moon. It has a big old crater on it that covers like a giant amount of its surface. But unfortunately, you can't see the crater in the picture that the NASA folks decided to pop into here. But it's also a cool moon. It's a little remarkable that it's actually in one piece considering how huge that crater is. But yeah, so interestingly, we had this debate about is Pluto a planet or is it a dwarf planet or something else? Like the cutoff between an asteroid and a planet, say. This is a similar debate because of Saturn and its rings about what's the cutoff between a moon and a moonlet or ring particle. So we're always learning stuff, or stuff that we thought was pretty fixed sometimes changes. And but you might be thinking, where can I see them tonight? And the next slide will show you where to look. So the moon will be your guide tonight, and you may already be able to see it. And so if you can, at sunset, right, a little after sunset, look towards the moon, and to the left of it, you'll see very shortly a bright star kind of pop out, and that will be Jupiter. And then that might be 10 to 20 minutes after sunset, maybe 30 minutes. A few minutes after that, you'll see Saturn. And they're actually going to be, like, if you can't see them tonight, don't worry, they'll be there the rest of the year. They're not really going anywhere. They will be moving closer together, and by near the end of December, I forget the exact date, I think it might be around December 21st or 23rd, you can check that later. They will be so close together, Jupiter and Saturn, in our sky from our point of view, that you'll be able to see them in the same field of view in binoculars or a telescope. So you get to see both the rings of Saturn and the moons of Jupiter in the same field, which is kind of neat. It's a nice little treat. And just one other thing, if you look to the right in this picture here, you'll see Antares, this orange star to the right. Now it's in the constellation Scorpius, and both of these will come up later. But the funny thing about Antares is you'll see how it's sort of almost in a line, like following Saturn, Jupiter, and the moon. That's part of the ecliptic. That's a term that just means the kind of the path that the planets and follow in our sky. So would Mars, say, go by Antares? And it actually would. And it actually does look fairly close in appearance. It's also red and about the same brightness sometimes. Mars actually changes its brightness quite a bit. Antares does not, but they named it Antares. The words literally mean ant, not, and Ares is the god of war, Mars. So it literally means not Mars. Mars was like a big problem for ancient astronomers, and so to the point where they had to take a star and just call it not Mars, so everyone would know not to confuse it. So you may be wondering, well, where is Mars? Our next slide will show you where that is. Oh, someone says, did you say we'll see Jupiter 20 minutes after sunset or sunset or moonrise? Oh, apologies for the mix-up. We'll see Jupiter 20 minutes after sunset, and that varies depending on your sky conditions and all of that. It might be a little earlier, might be a little later, but just look right after sunset because it'll be right next to the moon. Once in a while, someone can see so good they claim to be able to see Jupiter in the daytime. I cannot see that. But yeah, on our next slide, we can see where Mars will be. Oh, yeah, that's right here. Now, Mars is not going to be up right after sunset, but it'll be up maybe in an hour, hour and a half later. Start looking for it around 10:30. If you've got a clear view of the east, you'll see Mars, and you will definitely see Mars and be able to identify it, because the area of the sky that it's rising in is pretty lacking in really bright stars. The closest constellation is Aries, which is not very bright. And basically you see a bright red star rising in the east. That's Mars. And interestingly enough, I've found that Mars actually rises 14 minutes earlier for me. I live near Canada, than it does in the Bay Area. So that was a bit of a shock. So that's the difference latitude makes, I suppose. But yeah, if you look at it with binoculars, you'll still see a bright star. You might see a little bit of a circle. Mars and Earth are actually coming very close together in astronomy terms, and they'll be at their closest by October, I believe October 6th. They'll be about 38 million miles apart, which is extremely close in astronomy terms, but it's still pretty far away. But we did launch, you may have noticed in the news, we launched some missions to Mars late last month and early this month. And the reason we did that is to take advantage of this close encounter. It's a lot easier to send something to Mars if it's close by than if it's across the solar system. So timing is everything with rocketry. And since we're actually coming up on Mars, we can kind of just launch some rockets. The orbit is kind of doing some of the work for us. And then hopefully they get to Mars okay. And we'll know starting around January, February, March how those missions will go. If they get an orbit okay, land okay. Let's hope they do. And you'll notice that Mars will get much brighter by October as well. And you can start looking at it with a telescope now, and you might see a little bit of polar caps, maybe a little bit of surface detail. Mars is a funny planet because it's fairly small. And so if it's on the opposite side of the solar system from the Earth, or even not that close, we can't really see any detail, even with a very powerful telescope. But when it gets close, we see lots of detail. So that's why these close encounters are very important for astronomers and space missions. So have fun looking for Mars. Yeah, around 10:30, 11, you should be able to see it. But what else is there aside from some planets? The next slide will show you a fun thing to look for. The North Star. Now, the North Star might be one of the handiest stars to know in the sky. Now, it was especially handy back before we had smartphones with maps and all kinds of our modern conveniences to help us navigate, because the North Star is named the North Star because it is up in the north all night long. It does not move, unlike the rest of the stars in our sky that are actually moving from east to west. So you can imagine almost like a pole coming down from the North Star through the Earth, and we're kind of rotating around that pole. Now, you can use the Big Dipper. There's 2 stars at the end of the Big Dipper, kind of where you'd be pouring something out of, imagining it as a ladle. They point straight to the North Star. So they're called the pointer stars. So this is a handy little trick if you're, say, hiking around Mount Wanda late at night and your phone's batteries died because you're Instagramming some fun stories sitting on that little bench. You're like, oh no, I'm not sure if I'm supposed to go this way or that. The North Star might help you. And if you can't see the Big Dipper, that's actually not too bad a problem, because on the other side of the sky is Cassiopeia, which will look like kind of this sort of an M shape here. And it doesn't point directly at the North Star, but it kind of, I like to say, it gestures towards it broadly. So you can still kind of find your way with Cassiopeia. And actually you can kind of, if you're confused about the Big Dipper and Cassiopeia, you can kind of just sort of converge the views. And so that's kind of my little navigation trick. But you may notice this, if you have been looking at the Big Dipper, you might say, that doesn't look like what it looks like right now. The sky looks different. And you'd be right. You might notice there's a lot of snow in this picture, which was taken by Astro Bob, by the way, B-O-B. He has a great website, a lot of good tips, and he took this picture. But it was in the winter. The next slide will show you what it looks like tonight. So kind of on the opposite side of the sky. That's how people will call this configuration of Cassiopeia and Ursa Major and or the Big Dipper and the North Star, the celestial clock. So at sunset, depending on their positions, you can kind of tell what season you're in. So that's another little piece of time, celestial timekeeping and navigation. So that's just a fun little trick I've picked up from my boss, who's great. But what else is there aside from the North Star? There is, in the next slide is, as mentioned by a few people, a couple of things that you might want to check out: the summer triangle and also the square of Pegasus. But if you look straight up tonight, or you look up, might be a little here or there, depending on your latitude, right after sunset, maybe a few minutes later, as the stars are kind of popping in, these 3 stars here, Vega, Deneb, and Altair, they will be some of the first stars that you see. They're the brightest stars in their constellations of Altair is the brightest star, and Aquila the Eagle. And then Vega is the brightest star in Lyra the Lyre. That's the musical instrument. And there's also Deneb, which is in Cygnus the Swan. And they're all, so it's kind of an interesting way to see the difference between a asterism and a constellation. So the summer triangle has kind of a fun name, and it's very simply the brightest stars you see that form a pattern. It's an unofficial star pattern. That's what an asterism is. And the constellations like Cygnus or Lyra or Altair, those are actually constellations. They're the official names for these groups of stars. So people will use both, though. I like to use asterisms a lot because they seem to be a little better, a little more noticeable for folks. And someone said they liked Pegasus a lot. Pegasus will be up a little later. Like if you're looking for Mars, you'll probably be able to start seeing Pegasus around that time as well. And the summer triangle is named the summer triangle because it's up in the highest in the summer. But you see this big square of Pegasus, that comes up in the fall. So I like calling it sometimes the fall square, but honestly, the square of Pegasus is a cooler name. So, but it's sort of my indication that fall is coming. And that'll be rising low in the east, nearish on Mars, I think a little above it. So, and if we look, and actually, we're kind of done with our little star tour, and Hannah's going to put up a poll to ask folks what your favorite planets are. So what if tonight's planets are your favorite? Yeah, we got Earth, Mars, Saturn, and Jupiter. And yep, going to include Earth because that is a planet that we can see tonight. And there is a technical thing. You might be able to see Neptune or Uranus tonight too. They are up, but you need a pretty good telescope and a little bit of slightly advanced skill to be able to find them. Uranus is a little bit harder, easier to find than Neptune, but it's fun. Ooh, oh, I love it. Earth coming out on top. It is the one we need. Yeah, we got Jupiter running pretty high after that. Jupiter is very fun. It's one of my favorites. One of my favorite movies when I was a kid was actually 2010, the sequel to 2001, because I liked seeing Jupiter get turned into a star, which couldn't really happen, but it's a fun movie. Now, in our next slide, we're going to take a look at some lights you might see in the sky. Now, that aren't stars. I call them the moving lights. Now, what's interesting about going out to do some stargazing is the longer you're out, the more stuff you will see, provided you don't mess up your night vision by looking at any bright lights. Sometimes it's unavoidable, but especially if you're using an astronomy program on your phone, in that case, I recommend turning the brightnesses down as much as possible when you're going to use it. You can also find some settings to turn the screen red, which helps even more. Red light actually doesn't hurt your night vision nearly as much as other light. So that's kind of a little extra stargazing tip. And as your eyes are adjusting to this extra dimness and you're seeing more stars come out, you might notice a few stars or other star-like objects seemingly moving around the sky, possibly not making any noise, possibly looking pretty strange. So you might think, what is that? Is that a UFO? And technically, you'd be correct, because a UFO stands for unidentified flying object. Literally just means you don't know what it is. Doesn't mean it's a spaceship. Alien spaceship, because some of the things you might see are technically spaceships. They're just ours. So you might see airplanes, satellites, drones, meteors, and space stations, comets, and you might think, well, how can I identify these? Some of them might be pretty easy to identify, and you might be able to do that already. Well, let's take a peek, shall we? On the next slide, we're going to take a look at what I like to call the natural moving lights in the sky. And some of these are meteors, which you'll see on the left of the picture. Now, a meteor, you may have actually seen the meteor shower recently. The Perseids put on a really great show this year for several days straight. It was wonderful. The moon wasn't interfering too much, and you may have seen a few of them. Oh, someone asked what stargazing app is my favorite. Ooh, I'm really fond of Distant Suns, but there's a lot of good ones. Star Walk's very good too. I can't really play favorites. Different ones have different strengths and weaknesses. I use Stellarium probably the most on my computer when I'm doing stuff. Ooh, Sky Safari. That's a good one too. Yeah. Yeah, so meteor, the trick with the meteor is it's very brief. It's like a little streak. It's gone. And you don't want to use binoculars or a telescope to look at it because you'll miss them. You might catch one, but you're not going to see any. If you happen to catch something streaking across your binoculars, you still won't see any extra detail. Just fly back and enjoy the night sky at night, and especially in summertime. It's lovely. But sometimes a meteor flies for a little bit longer, is much brighter, maybe even makes a little bit of a noise. And that's actually what's called a fireball. And that's just something, maybe this size, but it burns up before it gets to Earth. There was a daytime fireball in Northern California a few years ago. I don't know if any of you remember, and I think they found some of its fragments. You could see it in the daytime, and I think they found some fragments in a Safeway parking lot in Nevada or something. I'm not entirely sure. But on the right is a comet picture, and you may have seen the comet recently too. This was Comet Neowise, and hopefully you're able to catch that before it kind of went on its way away from our sky. They move from night to night too. They don't really move so much when you're watching them like a meteor, but if you look at them through binoculars or a telescope, you will see them drifting along just past a little star. So, and night to night, they can book. Like they might be like in this part of the sky one night and then way over here. So comets are very fun. And in our next slide, we'll take a look at a few human-made moving lights. Now, the one that's become the biggest thing that's hardest to identify is, which star viewing app do I prefer? Oh yeah, I think Distant Suns is the one I'm using the most right now, but yeah, there's many very good ones. I can't pick a super favorite. If I'm getting real deep into something, like really checking stuff out and kind of plotting stuff, or I'm making star maps or trying to figure out where the comet's going to be when it's not very visible yet, then I use an app called Stellarium, which is also on the computer and the phone. And it's on everything. It's an open source program, and it doubles as planetarium software. It's very fun, and it's free, which also helps me like it a lot. Yeah. So, but for these human-made lights, you probably have identified an airplane at night before. It's usually pretty obvious. They have blinking lights, and I couldn't find any good pictures of an airplane's blinking lights at night for whatever reason, but I found this nice diagram of what they all mean. But depending on the angle at which you're looking at the airplane is taking off or landing or changing course, you might not see the blinking effect, or it might look very strange or eerie. Sometimes it might look like a triangle. And on the left, you might see all these little scattered lights there. I believe that was from a demo of drones using a swarm technology. And that just looks eerie. And drones move in a much different way than any other aircraft. So if you see a drone lit up at night and you don't hear the whirring noise, you might think you're seeing something from out of this world. But it is very likely a drone. Skyview is a good one. Thanks, Rowan, for stargazing apps. Rowan likes to use Skyview. Now, and the last thing, and the one that actually got me and my roommate one night, this was about 10 years ago when I had a nice balcony view in Oakland. Oh, how I miss it. We were watching, doing a little bit of stargazing at night, and then we noticed that there were 3 very bright stars right near the horizon that didn't seem to move and were kind of shifting around a bit. And we thought we saw a triangle-shaped UFO, and we were getting very excited. We thought we saw some cool secret technology or maybe an alien spaceship. We watched it for 20 minutes, and then they moved closer to us. Like, oh no! And then we started hearing the helicopter noises. It was just 3 helicopters in formation. There were traffic helicopters, and there was an accident nearby. So that was kind of funny. I was still stargazing a lot then, and I fell for it. So things can get really weird at night sometimes, depending on your point of view. And helicopters are in particular kind of notorious for that, especially if there's more than one in there. Just far enough away you can't hear them. Blimps! I got a call from a friend who thought they saw something flying overhead. And they did see something flying overhead, almost silent and with a bunch of lights blinking around it. It was a blimp returning from one of the games at the stadium. So, yep. So, but there's another set of human-made lights that, in the next slide, that are especially weird. And these are the ones you might definitely see at night and not know what's going on. And they're all related to rockets and satellites. The view on the left is actually a rocket named, it was one of the SpaceX Falcon 9 rockets. It took off from Vandenberg down in Southern California. And I took this picture from my yard in Richmond, in the Bay Area. I did not think I'd be able to see the rocket. And I felt something in the air and turned and looked. So you could even not quite hear the sonic boom, but you could kind of sense it. And that's when I saw this. And it looked eerie. And especially to add to the strangeness of these newer rockets is not just you get that launch blast, and I think that the weird colors there are from when one of the stages blew off. You know, a rocket goes up and it goes boom, boom, boom. Little pieces of it pop off. These pieces then land. And so not only do you see something break up, you see one thing become 2 things, and then one moves the other way. That looks very strange, but it's a lot of strange new technology in space right now. On the right-hand side is what's called I thought I got a nice picture of of a meteorite, and then someone pointed out that that is a satellite flare. And that's when a spaceship will actually reflect the light. And I'm actually looking to see if I have anything shiny near me. I don't think I do, unfortunately. I forgot the mirror. Oh well. But when a satellite is in orbit, a solar panel or antenna can actually catch the light. And what that does is it makes it get much brighter for just a few seconds, and then it dims down. It looks very strange when you see it. And especially if it's a satellite that was very dim and you may not have seen it earlier. So you may have just seen this flash of light for a few seconds and wondered what the heck you just saw. Normally satellites aren't quite that interesting there. You'll basically see a little star-like dot of light, and it'll just silently go across the sky until it either dips below the horizon or just vanishes. And that's because it hit the shadow of the Earth overhead. So and sometimes, like on that bottom right slide, you'll see these like a string of lights moving silently across the sky. That's very eerie looking. It looks very strange. And they're happening fairly regularly now. These are also from SpaceX. These are it's called a satellite train. So what they do now is, if you want to launch some satellites, try to launch as many as possible to save on your costs. So stuff 50 or 60 satellites into a rocket and launch it, and then they all kind of shoot out one after another, and then eventually break off into their own orbits over the weeks. So in case you see like a string of lights like moving very creepily across the sky, you're probably seeing Starlink satellites. So and those are kind of the biggest human-made lights that you're going to see in the sky. And I'm just curious to know if anyone here has seen, like after this presentation, has anyone seen any of these? And I'm wondering what you've seen. So in the next poll, you can let us know if you've seen comets, satellites, drones, that sort of thing. And maybe you've seen something that you still can't identify, and that's totally fine too. The night sky can be an interesting, weird place. Yeah, so yeah. Do you think you've seen a drone, a rocket, satellite, meteor, airplane? Could have seen multiple things. Maybe you've seen them all. Maybe you would like to see some later. And actually, speaking of rockets, I just saw this before we went on, and I don't know where they're launching from. Usually they launch from Florida, but once in a while California gets a treat. There's like 4 or 5 rocket launches over the next few days. So I think I saw it on a space.com, had a little article about that. But yeah, might be in luck if something comes out of Vandenberg. But yeah, let's hope.
David, this is Stephanie, and I was looking in the Q&A. We have some in here. If you wouldn't mind, maybe we can answer some of those while we got the poll up. This is going back. Someone was asking what the definition of like a moon is. What is sort of the definition of that?
That's a great question. And the funny part is it used to just be an object orbiting a larger object. And if you look at old space age stuff from like the late 50s, they'll actually talk about the artificial moons around Earth, like Sputnik. So that was before the term satellite came into wider use, because they were like, no, that's confusing people because they're not the moon, even though that is technically a moon, as in our old definition. So the current definition is basically, an object orbiting a planet, generally with some mass to it. Though, like, that's technically true to call, say, the space station or a satellite is a moon as well, technically. But practically, like, Earth has one moon. Though, if we capture an asteroid, as we did briefly, that asteroid briefly became our tiny little 500-foot wide moon or whatever it was before it left. Yeah, that's a very good question, and actually has some fun history behind it.
That's great. Thank you so much. Just one more, and then we'll show the poll results. Someone was just wondering how many, I mean, maybe impossible to answer, how many stars are there?
Ooh, trillions. Then trillions upon trillions. There's so many. But in our night sky, you can see, depending on your light pollution, maybe 100 or 200. I think a couple thousand is the usual amount from a fairly dark location that a person can see. That also varies depending on your level of night vision and how like good your eyes are and stuff too. But the short answer is the biggest number you can imagine. But practically, if you're like say out camping, a couple thousand that you can see. In our Milky Way, I forget the exact number, but it's also, I'll say the wrong number. I don't know offhand, but it's quite a lot.
Great.
Oh, I looked it up and it said around 100,000 million. That could be it. Thank you, Rowan. Ooh. Oh yeah, many people have, I think the number one thing people have seen is definitely at night is airplanes. You see them all the time. Not as many right now as we used to, but yeah, definitely lots of airplanes. And yeah, a lot of people have seen meteors, satellites. Some lucky folks have seen some rockets, and definitely some folks have seen some drones around their neighborhoods too. Cool. Okay, we can do more questions or we can go to the next one and come back. Which do y'all think works best? Ooh.
We can answer a couple more questions here.
Yeah.
Okay.
Ooh, yeah.
Okay, so back to Jupiter. Someone was asking what that big red spot is. Is it a never-ending dust tornado? Or what is that that's on there?
It is a sort of they're not sure if it's actually a never-ending storm. But yeah, it's very similar to say like a tornado or a hurricane, but the actual, I don't know what the nature of the material it is inside of it. It's probably, it might be, it's another sort of gas. I don't think it's very dusty on Jupiter, but there is a lot of weird chemistry in its atmosphere. It is definitely a storm. Then the thing is it's been going for about 400 years as far as we know, but it has been shrinking in size. So there's been some debate as to whether or not it's actually going away. So it may end at some point. It might not. It might take a long time. Maybe in our lifetimes it'll still be up. But yeah.
Great, thank you. And going back to the Saturn's own ring, I think you may have touched upon this, but what are they really made of?
They're mostly, there's some dust in there, but they are mostly made of water ice. Little water ice particles is the primary thing, but there's some differences depending on which section of the rings you're viewing at too. There's a little bit, but if you look up the NASA Cassini mission, they have a lot of extra info about that. They did some actual ring dives, which sounds very dangerous for a very expensive spaceship to do. But yeah.
Great, thank you. And then a few more. How many stars can you see in like a dark sky sanctuary?
Oh, I don't know the exact number. I'm so sorry, but it's many thousands. If you get in a super, super, super dark sky that's super high up, I don't know why the number 6,000's in my head. That seems too much, but you can see thousands. The Milky Way, for example, we're looking at our galaxy, which contains millions and millions of stars, and you'll see the Milky Way in the dark sky area spectacularly well. And to the point where you see a little bit of differentiation. Same with what they're called globular clusters. You'll even see little bits of them in more detail. So I'm very sorry that I can't give you an exact number, because if I did give you one, I would be lying and making a guess. But my guess is at least a couple thousand, and I'm very confident about that as a minimum. And then a maximum, I think, for some reason in my head it's 6,000, but double check that. And it will also depend on each site's viewing conditions too. So there's not a clear cut number, just to make it more complicated. Unfortunately, I'm sorry about that.
No worries, that's great. How about stars and planets? Do stars only twinkle? Do planets twinkle? I know my kids have asked me that question.
Yeah. Twinkling is a very weird, fun thing. It's actually, you're sort of seeing the atmosphere getting in between us and the stars and the planets. So the general rule of thumb is that the brighter something is, the less likely it is to twinkle. So the moon, you never really see it twinkle. It's also much bigger. So it's not like a point of light, because it's easier if it's like a little tiny point of light and some turbulence goes in between us and that object. But the short answer is generally stars twinkle because they're dimmer, and they're not quite as bright as a planet usually is. But if your sky is turbulent enough, you will still see planets twinkle too. I've definitely seen Saturn twinkle and Mars twinkle. I don't see Jupiter or Venus twinkle so much because they're much brighter, and Jupiter and Venus is close to us and sometimes almost shows a disk. Jupiter is so huge it also kind of has a little bit of a disk. So that kind of prevents them from becoming just a point of light that makes it easier to sort of twinkle because of turbulence. So the short answer, that's kind of like the reason why, but it's not 100%. If you see a dimmer planet, especially low on the ground, like right above the horizon, it's more likely to actually twinkle. Stars will very much, Sirius is actually a star that if you see it low on the horizon, a couple other stars are kind of brighter. They'll turn almost like red, blue. They'll change colors as they're kind of coming up right above the horizon because their atmosphere is also thicker when you're looking straight across versus looking straight up. So that also adds to the twinkling effect. So you might notice this tonight if you want to take a peek. Look at the stars low on the horizon versus the stars up high and see if maybe there's more twinkling in one area than another. So.
Great, thanks, David. And you can go ahead on with your presentation. Just wanted to get those answered. Thank you.
Cool, you're welcome. This is great. So, in our next slide, we're going to move on to a quick discussion about constellations. And so with constellations, the thing is we love to connect the dots, like in an actual connect the dots kind of thing, and also but also in the sky. And they're kind of our star stories. And people around the world in the old times, they had perfectly dark skies. When the lights went out at night, because the sun would go down and that was lights out except for the fire, most people kind of go to bed. A few people would stay up to kind of guard over folks or keep watch, or maybe they just like staying up. And they would kind of take a look at the sky. And after a while, you might get bored, or you might like to tell stories. You might notice certain stars appear at certain times of the year, and you might want to have a way to remember it. There's multiple reasons for coming up with different stories for the stars. You might not even need like a reason. You might just think it's fun to go, oh, that group looks like a bear. That looks like a raccoon. That looks like a ship. So the star is kind of almost like our Earth's cultural heritage in a way. And these different constellations are just our official names now for what these old star stories used to be. And cultures around the world have their own star stories. So you might look at, like we have one set of, you might think, oh, well, that's the constellation, Orion. But another culture might call it a different, they might have a different story entirely, a different name. They might even have different stars in that, like joining that pattern, or only half of them are right. So depending on where people are, they'll have different things that they call things in the sky. Someone that is living and working in a very cold climate with a lot of ice and snow, very far north or south, will have completely different views of the sky and different things to relate to the sky than someone, say, in a tropical environment, or someone that's lives on like temperate climate. So the stars will look different in different parts of the world too. And that all affects how we tell our different star stories. Oh, Hannah put in a great answer to an earlier question about how many stars you can see, and I'll just read that real quick. It's estimated that in Europe you can see about 500 stars in the naked eye, but out here, and that's in Europe with some light pollution, but in New Zealand star sanctuary you can see about 5,000. So my 6,000 number was not terribly far off. Thank you, Hannah. And yeah, it's actually easier to make star stories in a way when you have tons of stars that you can see. But luckily for us, because of light pollution, it actually makes finding the constellations a little easier for us because they're basically made of the brightest stars that are in the sky. So most of the stars that you're going to see in the Bay Area are the main parts of a constellation. So that's kind of a fun little tip. So if you learn the constellations, like in some light pollution, you'll actually have the experience of going to a dark sky site and wondering where the heck everything is. There's just so much now. It's a wonderful feeling. And in the next slide, we'll also explain a little bit about asterisms. We touched on this earlier, but you might have seen the previous slide that was Ursa Minor, but this is, or Ursa Major, sorry, but this here is just the part of the constellation that we call the Dipper, or the Big Dipper. So asterisms are unofficial terms that just kind of, it's almost like a nickname for the brightest part of a constellation or group of stars. Like the Summer Triangle is another asterism, or the Square of Pegasus is an asterism because it's just the square part of Pegasus and not the rest of Pegasus. Someone I know actually likes to call asterisms the MVPs of groups of stars because they're the ones you might notice first. So yeah, and they're just they're actually in a way just a new variation of our star stories. They're the things that we're seeing. So, and in our next slide, we'll take a little peek at one constellation that I kind of love this little star story bit, because many cultures, they look around the world and they see these stars and they have their own names for them. Usually they don't match up. Everyone sees their own thing. And the joke is, it's not really, it's a joke, but it's also kind of true that the constellations don't look like what they're supposed to be. You've even seen illustrations of like the Big Dipper or the Ursa Major. There's like a bear with a tail, which is even funnier because it doesn't look like a bear to me. And bears definitely don't have tails, but you know. However, Scorpius, which has that star Antares we talked about earlier, not Mars, to the right of Jupiter and Saturn tonight, and the moon. So the ancient peoples around the Mediterranean, like Greeks, Romans, Sumerians, Egyptians, they saw in this group of stars a scorpion. Interestingly enough, all the way over in Central America, thousands of years later, the Mayan people also saw a scorpion. They usually never match up, but it's also notable as one of the only constellations when I'll show folks at night and they'll go, oh, that looks like a scorpion. So it may be one of the few things that looks like what it's supposed to be enough that people just independently see it. So it's one of the few examples of the actual story involving these scorpions is a little different for each, but the fact that they saw the same animal is pretty cool. But most constellations, everyone sees a different thing. Like as we'll see in the next slide, there is, we'll just take a look at our good friend, the Big Dipper, or Ursa Major, as the full constellation. As you can see, you see the bear part actually takes up most of the part of the star pattern that we don't normally look at, which is the full constellation instead of the asterism that is the Dipper. And you can see the tail there that I don't understand why it has one. But that's what say ancient folks around the Med saw. However, and that's generally like the European version of that constellation, but the Inuit folks near the Arctic Circle in North America, they see a caribou instead. And where the tail of the bear is now the head of the caribou, because that was their big thing. They love like hunting the caribou, you know. It's not so much the bears there, though there are polar bears. And interestingly, in China, this is also an extremely important constellation, but it was actually called the government. And many of the individual stars or patterns in these stars were different parts, either government officials or parts of the government. And so everyone just brings to these names their own experiences. And which is why which is why in our next slide, this is my last slide for my presentation, we invite you to make your own constellations. So you can actually annotate the screen, and you might actually recognize some of these star patterns right now, but if you want, you can click the annotate option and trace and make your own constellations as we're all chatting here. We can answer some more questions while you're doing that, and yeah, just have fun.
Great, thank you, David. And I
You're
also
welcome.
put in some links in the chat as well to some of these activities like the constellation and links for the Breakfast Moon book and different resources, which are wonderful. A couple of questions we'll get back to. Does that sound good? Just a couple more. What is the smallest dwarf planet out there?
Ooh, don't know. That's a good question because the dwarf planet, there's another similar thing where there's even some debate about what's the cutoff between a dwarf planet and an asteroid. Currently, the largest one is Pluto, followed by Ceres. Wait, no, not Ceres. No. Ooh, yeah, because some of those outer belt objects are bigger than Ceres. Maybe. Smallest. Honestly, I can't tell you. I know the big ones. I'm very sorry for the smaller ones. But you can look up on, list of dwarf planets should have something there. NASA has a good list, and Wikipedia kind of copies from there. So, dwarf planets. But yeah, I don't know for sure. The general cutoff for a dwarf planet is it needs to be basically circular or spherical. So it's got enough gravity to kind of make itself into a nice little ball. And that's kind of the biggest part of it. There's a few more, it's kind of supposed to be sort of in its own orbit, but it can share the orbit with other things. So that's why moons aren't considered dwarf planets. Oh yeah, it's funny enough, I just looked this up and it even calls it list of possible dwarf planets because some of this is still under assessment. So yeah. I'm sorry, I can't give you a definitive answer. My apologies.
Thanks, David. Someone also asked about when the moon is rising, we often notice that it's very, very big, and then it kind of tends to get smaller. But why is it that it does that?
It's called the moon illusion. And I've heard people say that it's totally explained. And I've heard other folks in my office say that it has not been fully explained. It has something to do with the way our eyes and brain work together to process visual information. It's sort of related to if you've ever seen a mountain in the distance of the desert and you think that mountain is pretty close. And then you're driving and you're driving and you're driving, and several hours later, that mountain still looks far away. It's because of point of reference. So if you see an object pretty close to something, like that it's familiar to you, you can kind of gauge its size. But once it's away, you can't gauge it at all. So the moon is low in the horizon, it's close to trees and mountains, and it gives it this appearance of being much bigger. And then when it goes up, it's smaller. And it seems smaller. But if you measure it with, like, say, your finger or a thumb and kind of get the right size, you can look at it later and you'll notice that it matches up. So it has to do with the way that we just sort of, the general view is that it basically is like if we're having a point of reference. So when the moon is close to the horizon, there's a point of reference, and so we interpret it as being larger. But once it's further away, it's kind of on its own in the sky, and there's nothing near it, and it just kind of looks more isolated and smaller. So
That makes sense. I've seen that many times. And just one other question. Someone had mentioned when they were in Hawaii, Haleakala, if I'm saying that right, they saw an odd-shaped cylinder-looking asteroid, and one of the astronomers said that it was probably from another galaxy. So would you happen to know how they would determine that?
I think that's, there's been a couple now. I think the first one I saw was an object called Oumuamua, if I'm pronouncing that correctly. I hope I am. And it was the cylinder-shaped one. There was actually a book, I think in the 80s or 70s or 80s, called Rendezvous with Rama, which made people really excited because it looked like the spaceship in Rendezvous with Rama that came careening into our solar system. And everyone wanted to check out the cool alien ship. And the funny part is this did look cylindrical. It was like or for folks that aren't like a sort of this shape. And it wasn't quite from another galaxy, but from another solar system. Because we're all in this one kind of galaxy together as a big giant group of stars. Anyway, so coming from another star system is because of the angle of its orbit. Well, it didn't have an orbit. It was just literally how it was coming in to the sun, and the way it and then especially the way it whipped around the sun. They're like, oh no, this thing couldn't have come in from that angle if it was orbiting our sun at this speed. And then the way it went out, it just went back into interstellar space. So it's basically, they took a look at it, they plotted what they thought might be its orbit. It turned out to be not an ellipse, but actually a parabola, like something that just kind of goes out like this, like a U shape. And they're like, oh, well, that doesn't orbit the sun at all. That came from somewhere else. So that's how they figured that out. And since then, they found a few more that are doing that. And interestingly enough, they found a few objects in our solar system that now they're wondering, well, if something came from another star system and passed through, isn't there a chance like Jupiter or like the sun or Saturn or anything could have maybe captured it and made it its own moon or another asteroid or Kuiper Belt object or maybe dwarf planet? So that's a fun little side topic that people are starting to get really excited about, because it's very hard to get to another star system. But if another star system can send a little sample our way, we can check it out much easier. So, yeah.
Thanks, David. And I know some people are having trouble with the annotation. We're trying to fix that to be able to do that. It's kind of fun to do. I like some of the drawings. Another question, what are some of the dwarf planets? I wasn't sure if you had named some of them earlier.
Oh yeah, there's some really fun ones. There's Eris, which was, I think, the planet that was, or the dwarf planet that was found that kind of set off all the chaos about Pluto's status as a planet or not. There's a Maki is another dwarf planet. Ceres is another one. That's actually an asteroid in the asteroid belt. And it was funny enough, Ceres used to be named a planet in the 1800s until the same thing that happened to Pluto happened to it. For the longest time, there was Ceres, Vesta, Pallas, several other larger asteroids. But that's all people saw at the beginning of the 19th century. And so like, oh, I guess there's a few little planets in between Mars and Jupiter. Well, that's cool. That makes sense. There should be a planet there, according to our theory of where planets should be. There used to be this weird, they called it a gap. And then they found a few things and they're like, oh, I guess instead of one big planet, there's a few smaller ones. That makes sense, I guess. And then around the end of the 19th century, telescopes got a lot better and they started finding hundreds of asteroids. And they're like, oh, we need to not call this a planet anymore. Let's call it an asteroid. That's a new term we invented to not call it a planet. So, and if you see old textbooks from like the mid 1800s, it'll say our 12 planets or our 13 or 14 planets in our solar system. It's kind of a trip to see. So, yeah, so there's a lot of fun with the dwarf planets. They're all really neat little worlds. Ooh, that's a good one from Guy.
Right, yeah, I was just going to say that, the International Space Station. That's fun. Great.
Yeah, thank you, guys. That's a big thing. It's actually the brightest satellite you're going to see, and I'm so sorry I didn't mention it. You can actually go to spotthestation.nasa.gov, and you can actually get a little schedule and text alerts for whenever it's going to fly overhead. It is very bright, and it takes a minute or two to cross the sky. It's great. I love the space station. So yeah.
Well, great. It looks like we've got almost, yep, we have all the questions answered. So I think this has been an awesome presentation. Thank you so much, David.
Oh, you're welcome.
Yeah, we'll turn it over, I believe, to Hannah next.
Yes, thank you so much, David. Thank you, thank you, thank you. I really appreciate it. It's really nice to see someone who's really very clearly passionate about their work, and thank you for sharing it with us tonight.
It's been my pleasure. I love doing stargazing with y'all. That's great.
Thank you. Yes, we worked with David out at Twilight at Fernandez Ranch and now here virtually. So we're happy to get to work with him and look forward to doing that in the future. We've just got a few more slides left. If we could show the Visit app, great. So if you have become energized by this presentation and energized about space, and you like hiking, you may want to take a hike that shares facts about astronomy and the planets at Fernandez Ranch. And you can do that on a 3-mile trail at Fernandez Ranch. We have scaled the distances of the planets so you can get a real sense of our vast solar system using the Visit Mobile app. Once downloaded, the Visit Mobile app will automatically notify you of key points or planets as you hike. And there are 4 other tours as well on our properties. I highly recommend them. So check that out. And also, on the next slide, I will be inviting you to join us for Biodiversity Month this September, along with the Department of Fish and Wildlife. You can visit our Facebook page to join in on that fun, or our website. We've just got that event up on our website today. And David, do you have any events coming up that you'd like to share about?
We do not have any at this any big events. However, there is one. On Monday afternoons, the Astronomical Society Pacific does a story time where they read a children's book relating to astronomy or space exploration. So if you go, they put the latest schedules up on their feeds. So if you go to at Astro Society PAC or Astro Society PAC on Twitter or Facebook, you will definitely be able to check them out and go to their website, and they'll have more details as well.
Perfect. That sounds like fun. Thanks for sharing. And if you want more information from David or myself, the next slide will show you our contact information. So David's information is on the left there. His email, dprosper@astrosociety.org, and myself, Hannah, at jmlt.org. And thank you so much, all of you, for joining us this afternoon. We really had a great time. Thanks to all the presenters here and facilitators. And with that, we'll sign off and wish you a happy evening and good luck seeing the stars and planets and whatever of those lights in the sky that you'll see tonight. Enjoy.
Fun, everyone.